Hello, in this class more post-processing tools will be shown for CivilFEM results as utility of using clipping planes so you can see results inside the structural elements, how to animate the results, and very interesting as well to get a chart of certain results in nodes or elements along all the results files. Very interesting and useful when you have a non-linear analysis or a transient analysis where you have many lot steps divided into fractions. We will use this example already available. We will use the results file of this example to show in this class. If we continue with the post-processing, we have this example which is available in the work examples section. 3D solid beam, the crack analysis under shear failure. We have this solid model, no shear lengths were defined, only longitudinal bottom bending reinforcement. In this case, it's a non-linear analysis, and we divided the step into different steps. The lot case was divided into 14 fractions. To see the incremental results, this checkbox must be activated, create incremental results. So once we solve, we will have the unique lot case divided into 14 because it was the last converged solution. You can click on information and you can see here a detail of the solved lot cases. In this case, we can use the history plot to see these partial results. Monitor is the pattern of the cracks. An interesting view util is the clipping option. Plot, for instance, stresses in megapascals. We can go here and click on clipping plane and check internal results by this cutting plane, in this case in positive y direction, and we can check and monitor, and we can animate it as well, the stress in both concrete and rebar steel, but inside the section. Of course, can be animated, can select different load cases. We select the result type, set the time per result, minimize and here you can see how the result is animated through all the intermediate load cases. Here in the history plot, we can select different results. We can monitor the total displacement in millimeters, the final deflection until the collapse of the structure, until the failure of the beam is 10 millimeters, and we can as well check the applied force, Z, 44 kilonewtons. We can select a node of the support, or better from here, and another node for the displacement in the half of the span. We open the history plot and we choose one result. To add a new result, click here. We select the type of result, nodal, end, or stress and strain, or displacement or reactions. The code of the result will be here for stresses, displacements. So if I want to plot the historic results for vertical reaction in kilonewtons, just select this result, set a name, plot it. Here we can check that here there's a change in the behavior. At this point, at the 40, almost linear until 40 kilonewtons of force, and finally it collapses at almost 44 kilonewtons. We can monitor as well the displacement, the deflection, how to say here. Here it is. the deflection 10 millimeters, and we can set the displacement, the deflection, as one of the axes and plot deflection versus force. We can check here that at 40 kilonewtons there's a deflection of 7 millimeters until the final step, which is 10 millimeters at 44 kilonewtons. So here are some of the options that are very useful for plotting results. Thank you very much. Stay tuned and see you in the free course.